Hey there, science fans. Have you ever noticed something really strange about ice? It floats in water. That might not seem like a big deal, but think about it. Most things get denser when they freeze, meaning they get heavier and sink. So why does ice break the rules? The answer lies in the wacky world of science. You see, water is a special substance. It behaves differently from almost everything else when it freezes, and that difference is what makes ice float. Stay tuned, science explorers, as we dive deeper into the mystery of floating ice. To understand why ice floats, we need to talk about something called density. Density is a key concept in science that helps us figure out why some things sink and others float. It's not just about how heavy something is, but how much mass is packed into a certain amount of space. This idea is super important when it comes to understanding ice and water. Density is how much stuff is packed into a certain space. Think of it as how tightly the molecules or particles are squeezed together inside an object or a substance. Imagine a box full of feathers and a box full of rocks, both the same size. Even though the boxes look identical on the outside, what's inside makes a huge difference. The box of rocks is heavier, right? That's because rocks are packed much more tightly than feathers, so there's more mass in the same space. That's because it's denser, more matter is packed into the same space. The feathers take up the same volume, but they have less mass, so they're less dense. Now you might think ice is denser than water because it's solid. After all, most solids are denser than their liquid forms, right? But here's the twist. Water actually becomes less dense when it freezes. That's why ice floats on water instead of sinking to the bottom. How is that possible? It seems to break the rules. Well, it all comes down to the way water molecules arrange themselves when they turn into ice. When water freezes, the molecules spread out and lock into a special pattern, creating more empty space between them. Fasten your seatbelts, science adventurers, because in the next section, we'll uncover the secret weapon that keeps ice afloat, buoyancy. Get ready to dive even deeper into the science behind floating ice. Buoyancy is like water's way of pushing back against gravity. Imagine you're at a pool, and you try to push a beach ball underwater. The harder you push, the more the water seems to push back, trying to pop the ball back up to the surface. That invisible push is buoyancy in action. When something is in water, the water pushes up on it. This upward force acts on everything from tiny grains of sand to massive ships. It's the reason why you feel lighter when you're swimming or floating in a pool. If the object is denser than water, the water's push isn't strong enough, and the object sinks. That's why a heavy metal key drops straight to the bottom, while a wooden stick bobs on the surface. But if the object is less dense, like our friend ice, the water pushes upward with enough force to make it float. Even though ice is solid, it's actually lighter for its size than liquid water. So ice doesn't actually defy gravity. It's simply taking advantage of the rules of physics that govern how things float or sink. Instead, the upward force of buoyancy is stronger than the downward pull of gravity on ice. This balance of forces is what keeps ice at the top, gently bobbing on the water's surface. It's a scientific showdown, and buoyancy wins. Every time you see something float, you're witnessing this invisible battle between gravity and buoyancy. But what makes ice less dense than water? Why does it float when most solids sink in their own liquids? The answer lies in the way water molecules arrange themselves when they freeze. Get ready to explore the science behind ice's unique structure in the next section. We'll uncover the secrets that make ice float and see how this simple fact shapes our world in surprising ways. When water freezes, something truly fascinating happens right before our eyes. It's a process that might seem simple, but it's actually packed with science and wonder. The water molecules, which are always moving and jostling around in liquid form, start to slow down as the temperature drops. Instead of clustering together randomly, they arrange themselves in a very special, spread-out pattern, almost like dancers forming a perfectly choreographed routine. This unique arrangement creates a beautiful crystal structure, almost like a tiny, organized jungle gym made entirely out of water molecules. Each molecule connects to others in a repeating, hexagonal pattern, which is why snowflakes and ice crystals have such intricate shapes. And here's the really cool part. All those open spaces within the crystal structure mean that ice is actually less dense than liquid water. That's why, when you drop an ice cube into your drink, it floats right to the top instead of sinking. So there you have it. Ice floats not because it's defying gravity or doing something magical, but because of the scientific principles of density and buoyancy. The way water molecules lock together in ice makes it lighter than the water it sits in. Who knew that something as ordinary as ice could be so complex, so full of hidden science, and honestly so cool? Next time you see an ice cube floating, you'll know the amazing reason why. What do you think about this icy explanation? Does it make you look at your glass of water a little differently? Keep those science brains buzzing, stay curious, and keep searching for more amazing facts about the world around us, because there's always something new to discover.